What do we have here? It says subcooling is not important to heat pump performance. Well, I feel like you guys might have some thoughts on that. I guess this is in reference to folks who are really just paying attention to superheat, or
Well,
what are you thinking?
whether it's an inverter driven system or a standard system, having a solid column liquid behind that metering device so that we can feed the evaporator coil is just as important on any system, any HVAC system. Whether it's inverter driven or not, the basics behind air conditioning haven't changed. And the basics have always been, your evaporator temperature should be around a 40-degree coil. Yeah, they'll run 32. Yeah, they'll run 50. But in order for that evaporator to have the proper amount of refrigerant in it, it has to have that solid column liquid behind that metering device. And that's where subcooling comes into play, measuring subcooling. When it comes to inverter driven units, it's a little different in compared to single speed systems or two-stage systems where you can lock that speed in and have a known subcooling. When it comes to inverter units, we've got units that might be running at 30 hertz, it might be running at 50 hertz, it might be running at 80 hertz. So there's really no way for the manufacturers to give us specified subcooling numbers to be able to charge like that. So you're better off to. That's why we constantly say on inverter driven systems, if there's a charge problem, we know the unit was low on charge, we know the unit had a leak in it, had to be fixed, whatever the case may be, the final recharge of that unit needs to be weighed in because they can't give us those critical numbers for field type of charging, put it that way. Yes, they know that stuff in their plants, in their factories, all their engineering data and everything they run to know how much charge has to be running to them, but it gets way more involved than what we can do in the field as far as adding charge. Now, I'm not going to say, and I've told guys this before, even on I'm working on a mini split on the phone or working on even a GMB unit, or no matter what it may be, I'll tell them, look, man, I know you're busy. So if you know it's low and you can charge it to where you get a decent temperature differential across the indoor unit, you're running a decent suction pressure compared to when you first got on, it was running 20-degree evaporator coil. You know it's low and our discharge temperature is reading high. Then, yeah, add some charge to it, get them going until you got the time to come back and do a full repair. So you can't always get away with doing that, but it's definitely worth that shot. I mean, if you know it's low and you don't know exactly how much, slowly add some charge and see if we can't get those numbers looking a lot better and get the temperature splits across the indoor units where we need them to be without getting too much refrigerant in it to work, because again, the GREE systems do a great job of protecting themselves. So if it's running a little low on charge, that's not going to throw it out on an air coat. It's going to limp along and run still. So add some charge into it to where we get a little bit out of that limp mode and more into a decent temperature differential across the indoor unit. And then come back when you got that 4 hours or whatever you need to actually go in there, find the leak, repair the leak, and do a triple evacuation and weigh the charge back in. That's just my suggestion. And I've had guys do it on the mini splits many a times, and they'll typically charge them until they get like a 20-25 degree split across the indoor unit, and then they come back when they got more time because that day they've got 4 or 5 service calls after that call. There's nothing wrong with that, and that's not what we're trying to tell guys. They're like, what do you mean I have to weigh the charge in? What we're telling you is you have to weigh the charge in if you want it done right. Doesn't mean you have to do it right that second. You may need to just get it to limp along better until you have the time to come back and actually make the full repair.
Right. Well, I do get asked sometimes, like the multi-pro systems can do 295 feet from the outdoor unit to the indoor unit. And they're like, how? A big reason for that is the fact that we do have a subcooler in the outdoor unit that can maintain that subcooling. So like we might need quite a bit of subcooling to be able to do that without absorbing a bunch of heat on the way in. Or if we've got, a multi-zone style system, like a multi-zone multi-pro system, where we've got multiple indoor units, we're going to have a significant amount of subcooling as we pull liquid off of that liquid line, going to one unit and going to the next unit and going to the next unit, well, you're going to have a fair amount of subcooling to be able to do that. You want a solid column of liquid. If you do not have a full column of liquid, you're going to have bubbles. And if you got bubbles, you got poor cooling performance, right? So, charging these units just based on subcooling, I mean, yeah, you can get there. You can get to something that looks more normal that day. People will often ask, like, if you could just lock it in, do a maximum level, that kind of thing. I'll be honest with you. If you have an inverter driven system and they give you a chart and it says something like 9 to 19 on the subcooling chart, something like that, it's typically not from the factory. It's typically from somebody else, somebody like me, or Greg, or Jesus at a different company that just says this is what we've seen, a certain range, and that's something. If you thought it was low in refrigerant and you're adding refrigerant, it does get you closer to what it should be by adding refrigerant, right? But it's not, tricking it into running 100%. There's not really a way to do that because, built-in protections are going to come into play. They're absolutely going
Well,
to do that.
and
Standard
also the
system, if you ran it like that and you just continue to run it like that and it ignored any kind of input, like you just put jumpers on Y, right? And you're just cooling. Yeah, I mean, if you dropped airflow out, is it going to freeze up? Or like if it just continues to get cold in the space, is it going to freeze up? Are you going to return liquid to your compressor? Are there any protections to prevent that? No. So you can't do that with an inverter driven system typically. You can go to max, you can try to get it to max, but it's going to provide you the maximum amount of capacity that is available at those temperatures. Like I only got to run so fast on an 80-degree day to give you 3 tons. And when it's 100 degrees outside, I got to run a little bit faster to give you 3 tons. If I locked it in, I'm giving you significantly more capacity. You're running it outside of norms at that point. You know.
well, I mean, and just to mention, like you said, a lot of these units, like the GMB units, the multi-pro units, have subcoolers in them. So if the system's low on charge, it's already trying to save itself by subcooling that refrigerant more using the subcooler. So we're going to be utilizing the subcooler more if we're low on charge and less if it's got the right charge, right? So how do you figure out what that charge difference is as to when that's all proprietary information that the manufacturers are not going to give you as to exactly when and how they calculate when the subcooler is going to be, subcooling more refrigerant versus less refrigerant. It's a lot of math and a lot of programming involved into the whole and all the thermistors and stuff that it's looking at. So, to get the efficiencies that these machines give us, which is exceptional, and the performance that they give us, yes, unfortunately, it's going to be different than a unitary product where you can lock the speed and say, okay, here's my subcooling is where it's supposed to be, my superheat's where it's supposed to be, my airflow is where it's supposed to be, my temperature drop's supposed to be, that unit's charged.
Right.
But so I guess I'm just trying to make sure everybody understands the point that if you're getting into the higher efficiency units and the higher performance of those units using an inverter driven unit, it's going to have some of its downfalls too. In that when you go to add charge, yes, it's not going to be as
Yeah, I
simple
mean,
as
you can
start
take a
to
basic single
take
zone
in.
mini split, for example, and you're going to have, a dozen variables that are being monitored at all times.
Right.
Outside temperature, inside temperature, liquid pipes, suction pipes, speed of the compressor, speed of the fan motors, both inside
Step of
and
the
out.
EV,
Yeah, EV
all of that.
positions, all of those things all at once. And I mean, the way I learned it was I have one clamp on thermometer and I know the saturation temp.
Yeah, and how many thermistors you have on that same machine? So they got a lot more
7.
thermometers on there than we do.
Yeah, right. So it's looking at the same things that you would look at to determine whether or not it can run properly. And that's the reason why we end up with the error codes and stuff like that. But I mean, if you think that you've got a reduction in capacity and you've eliminated airflow both indoor and out, right? If you eliminated airflow, I mean, the other thought process, of course, is if you thought you had a leak, there is a repair that should be done at that point, right? We
Right.
know it's leaking. There's regulations behind all that. Um,
Well, in our tech department, and myself too, will say repeatedly, When you take it out, weigh it out. When you recover the refrigerant, weigh that tank before and after you're done recovering that refrigerant. That way, you know exactly how much refrigerant you pulled out of that machine. And if you know the calculation and you get the total charge amount that's supposed to be in there and you pull out significantly less, then you absolutely know there's definitely a leak in the system somewhere. And we got to find that, get that corrected before we weigh that charge back in.
Right. I mean, well, you and I had a commercial job site not too long ago. They first went out in the spring, added some refrigerant. They go back out a couple weeks later, they add some more refrigerant, and so on and so forth. And then when they finally, because I mean, it's heating up, right? It's heating up because it's spring. It's heating up, so it works okay for a week or two, and then it heats up a bit more. Then it's not working that great, so they add some more, and they add some more, and they add some more. And they ended up, just being grossly overcharged. There's other reasons why these systems may not be performing properly. Um, so when somebody just says, "I checked the charge," it's like, okay, what did you do? Even with the service tools that we have, it's still a lot of data all at once that you're trying to figure out, and it can be very difficult to figure that out. But I mean, you can know without a doubt. Um, if you were looking at discharge temperature, and when that unit first cranks up, it ramps up. That discharge temperature ramps up with it. It gets real hot, gets up to like 200 degrees, and then it slows back down and kind of chills there for a while. You don't have the volume of refrigerant that you need. It doesn't need necessarily. It could be other things why you don't have the volume. You could have a restriction. The EV could be stuck. It could be a lot of things. Um, but that's usually a pretty clear indication. But
So I can
no,
give an
yeah,
example
go
on
ahead.
a scenario with a multi-zone mini split. This was in another life for me. I wasn't working where I am today, but I was also in this support role of technical support on this for mini split, and it wasn't a GREE unit. It was a completely different manufacturer, but it's kind of all the same thing, right? The contractor called me and told me the system wasn't keeping up, wasn't going properly, no error codes. I says, okay. On that particular machine, you can go out of the outdoor unit, you can toggle through all the thermistor reading. So I emailed him exactly how to get into that and how to record all that data. Now, unfortunately, it was in Celsius. On that machine, there was no way to change it to Fahrenheit. And I said, so now I want you to go back on the job. This job had 4 indoor units. And I said, I want you to let that thing run with 1 indoor unit for about 5 minutes and record the discharge temperature and all the other temperatures. And then I want you to let it run for another 5 minutes with 2 of them running, then 3 of them running, then all 4 of them running. And the guy calls me back next day and goes, I got your data. I go, my data? That's your data. Did you try to digest it at all? He goes, no, I just gathered the data. I says, okay. Did you convert it to Fahrenheit so we can understand it better? No, I didn't do that either. Okay, send it to me and I'll do it. So I did it. I converted all to Fahrenheit. I called him back. I emailed it to him. I'm like, now open this up and look at it. I said, tell me what's wrong with that unit. He goes, I have no idea. I says, well, if you look at it when one unit's running, the discharge temperature was not that bad. And as the second one came on, the discharge temperature went up more. And then as the third one came on, the discharge temperature went up even more. And then when the fourth one come up, it was really getting into some high discharge temperatures. I says, what do you think that means? He goes, I don't know. I said, it's low on gas, man. You got a leak. And he goes, oh, that does kind of make sense. So then I seen him about a month later at a training class I was doing. I said, so whatever happened with it? He goes, you were right. It had a leak in it. So what I'm saying is, and I'm not trying to be, know-it-all or anything like that, but that is there for a reason. If you're running 155, 165, 175 discharge temperature, that's not that bad. You start seeing discharge temperatures off your compressor at over 200 degrees, you're not getting enough refrigerant back to that compressor. You don't need to know specific numbers. You just need to know what's definitely not good. And over 200 degrees, actually, even over 190 is entirely too hot.
Right.
So,
Right.
and that doesn't matter if it is a mini split Or if it's unitary product, a single stage system. Discharge temperature is discharge temperature. The warmer the gas goes in, the warmer the gas comes out. Because all the compressor does is compress it.
Right. All right. Any more thoughts on that?
Yeah,
Mr.
I was
Cook?
just gonna add about the subcooling and it being important. I mean, let's not forget the reason why we turn to inverter systems is to get that efficiency that that is promoted, and it's there, but we do have to have those parameters correct, and that means having correct refrigerant charges, having correct line sets, having correct pretty much applications versus indoor and outdoor. So yeah, subcooling absolutely critical to get those numbers that we see and that we get excited for when we see them.
Yeah,
So
I'm
it's
so
just
glad
to add that.
you brought that up, Jesus, because I didn't even bring up the fact about refrigerant line sizing, because we repeatedly get asked the question, "Hey, we already put all this piping in. It's not the right size. It's supposed to be this. Is that okay?" No, it's not okay. You got to go by the manufacturer specifications for all these reasons that we're talking about, as far as getting the charge right and everything else. And then also with mini splits or uh, multi-pro on indoor units, what you got to remember is that suction gas line in cooling is, if it's the wrong size, let's say it's small, maybe it's supposed to be 5/8 and you only got half inch, or maybe it's supposed to be half inch and you only got 3/8, whatever. Okay. Remember, that is your suction line in cooling. In cooling, it's probably not going to be a problem. But when you go into heating mode, that same pipe just became your discharge pipe and it's too small. You can't have too small of a discharge pipe in heating mode. That's where it's going to be a problem. And we've seen that many a times on the multi zones where they use the wrong size line set. And they said, well, run fine all summer. Well, yeah, it will. Then when you get into wintertime and that discharge line is too small, that's a problem.